Earlier I have solved a problem regarding the settlement of pile group. Then I have started this negative skin friction for single pile, and where this negative skin friction occurs, what are the conditions. Then how to find it out negative skin friction of single piles, both cohesive soil as well as cohesionless soil. Then considering group of pile, how to calculate negative skin friction. First one, considering group of pile, consider as a single pile failure. Then second one, considering as a block shear failure. So out of these two, maximum value has been used as a negative skin friction of group of piles. This is all about pile foundations. Almost every part is over. Basic part of the pile foundation is over. Now let us start with this a new chapter, that is your well foundation. Well foundation, it comes from Casson. It is called also Casson foundation. Casson is a French word. It's a French word. Casson means chest or box. So particularly it is either chest like or box like structure. That means it may be rectangular or circular, which is sunk from the surface of either land or water to soil desired depth. That means it is a box like structure which is sunk from surface of either load, surface of either land or water to some desired depth. It is a box like structure which is sunk from the surface of either land or water to some desired depth. So, if I put it into Casson foundations, here it will be there are three types. One is your box Casson, second one is your open Casson, and third is your pneumatic Casson. So, let us start with this box Casson. Box Casson is open at top and closed at bottom, and made of timber, reinforced concrete or steel. Timber or reinforced concrete or steel. So, built on land, look at the difference. Built on land, then launched and floated to launched and floated to pier side. And another important part is box caisson is provided where bearing stratum is available at shallow depth, where bearing stratum is available at shallow depth. After box caisson, second one is your open caisson. It's a box of timber, metal and reinforced concrete, and it is open at both the top and bottom. Top and bottom, used for building and bridge foundations. Used for building and bridge foundations. Third one is your pneumatic caisson. In pneumatic caisson there is a working chamber in which compressed air is forced inside. Compressed air is forced to prevent entry of water, So, in the caisson foundation, it is called well foundation or caisson foundation. Caisson come from the French word, particularly it is French scientist who has started this. It meaning is chest or box, and it has been classified into three subcategories. First one is your box caisson, second is your open caisson, third is your pneumatic caisson. In box caisson, open at top and closed at bottom, made of timber or unreinforced concrete or steel, built on land, then launched, floated to pier side, means built somewhere else in the land, then it has been launched to actual site, and it is suitable where bearing strata or bearing stratum is available at shallow depth. Second one is your open caisson. Open caisson is your, it is a box of timber, reinforced concrete, and it open at both top and bottom. Look at here, it is open at top and bottom. Here in box caisson, it open at top and closed at the bottom. Used for building and bridge foundations. Pneumatic caisson, in that pneumatic caisson there is a working chamber. Inside this working chamber, what will happen? There is a compressed air. So, it will allow or prevent water to flow inside. What is the advantage of providing well foundation than our regular deep foundations? Somebody can ask questions, why I, in which condition or why I will go for well foundation rather than providing deep foundations. Of course, well foundations are also deep foundations. So, Advantage of your well foundation. Whenever bearing capacity of foundation is taken to a depth more than 5 to 7 meter, more than 5 to 7 meter. So, in that case what will happen? Your open excavation becomes costly and uneconomical. Second part is your, this is part 1 advantage. Second part is your, in adopting ordinary type of floating, is that excavated material refilled around the structure is loose and easily scourable. What is the advantage? First one is your bearing capacity of foundation. It requires more than depth of 5 to 7 meter. What will happen? There is a water is going on. Suppose there is a case here, there is water is passing through from this section to this section. So, bearing capacity of the foundation requires more than 5 to 7 meter. Then what will happen if you make a trench open excavated? What will happen? It will scoured, it will taken out by water currents. So, in that case you go for massive well foundations or caisson foundation, provide it so that it become stable. Next part is your shape of wells, different types of wells or shape of wells. First one is your circular. How it looks? Generally, if you look at the railway bridge passing over a river, it is a circular. So, first shape is your circular. What are the features here? High structural strength, and convenient in sinking, that means it conveniently go inside the water and sink well. Suitable for piers of suitable for piers of the single line railway bridge and double line road bridge. Maximum diameter is limited to 9 meter. Circular. Second one is your double D well. Double D well. In double D well, this is the shape of the double D well used for piers and abutments. Of bridges which are too long to be accommodated on circular well of 9 meter dia, which are too long to be accommodated on a circular well of 9 meter diameter. Then second part is your double octagonal well, third is your double octagonal well. How it looks double octagonal well? What is the advantage of double octagonal well as compared to double D well? Offer more resistance than double D wells against sinking. Then D is your twin circular. Twin circular shape. In twin circular shape, how it looks like? This is the shape of your twin circular. Two independent well placed very close to each other. Two independent well placed very close to each other and have a common well cap, having common well cap. The wells are sunk simultaneously. It is used when depth of sinking is small, when depth of sinking is small and bearing capacity of soil is high. Then last one is your rectangular well. How it looks like? It is generally used for bridge foundation. Of 7 to 8 meter depth, and for large one you can go for a double rectangular well. Sometimes also you can use, sometimes also you can use double rectangular well also, sometimes you can use it. Let us look at this a cross sectional view, what are the different parts in a well foundation. Then we will make it one by one its definitions. Here if it is pier, different component I am talking about. This is your RCC slab. This is your cement concrete. And this is called well cap. This generally has been done by means of concreting. So, this is called your this part is your curve. This is your cutting edge. This is called bottom plug. It made of cement concrete, and this is your sand filling. This is D0 and this will be DI, and this part is called staining. RCC slab, cement concrete, pier, and this is a well cap. This is a staining, there is a curve, and at the end if you look at the cutting edge is always outward. Cutting edge is always outward. Outward means once you penetrate inside the ground surface, it will cut outerly. So, it has been done by manually or by means pneumatic or by machines using, it has been done. So, if I take a cross section of your well, how it looks? Pier, RCC slab, cement concrete, well cap, staining, curve, cutting edge and bottom plug. This is how it looks like. Some of the few terminology, like if you look at the components, what are the major components? Major component, first one is your cutting edge, second one is your well curve, third one is your well staining, fourth one is your bottom plug, fifth one is your top plug. There are 5 categories. First one is your cutting edge, second is your well curve, CURB, third is your well staining, fourth is your bottom plug, fifth is your top plug. These are all the part, and in detail I will discuss maybe tomorrow or sometimes after that. Then I will go for stability analysis. What are the different point of view how the stability analysis has been achieved, and detailed design is your out of your scope, and 1 or 2 problem I can solve it. So, I can stop it here, maybe next class I will further continue about the detailed component part of your well foundations. Thank you.